Hello, let's look at these four questions that we had on our quiz. So let's take a look. The first question, of course, we wanted the derivative. So we wanted dy dx. So how do we see this function? How do we see this function? We talk about that this function, cosine square x, means that's the cosine x multiply cosine x. Okay, so you could do product rule, and you can also do chain rule. Okay, if we do product rule, you just the product, right? You differentiate this one, and you differentiate the other one, and then you're gonna get negative sine x, and this one is a cosine x plus. Over here is a cosine x multiply negative sine x. Okay? In the end, you're gonna get negative 2 sine x multiply cosine x. And some of you use the double angle formula, which equals to, 2 times sine x cosine x, that's sine 2x, so that's gonna be negative sine of 2x. Okay, so you can do it this way or by chain rule. If we differentiate by chain rule, right, and we're gonna see this as cosine squared x, cosine x being squared. And then when we differentiate, right, we're differentiating something squared, okay, something squared. We'll assume that this is going to be u squared. And with respect to du, and on the other side, it would be du with respect to dx. And of course, u is the cosine x, right? So that's how we get 2 times u, right? 2 times u, and u is a cosine x, right? And the derivative of cosine x is negative sine x. Don't miss this parentheses. If you miss this parentheses, it will be regarded as subtraction. So this parentheses is essential. Without it, you're losing a point. In the end, we get a negative 2 times sine x cosine x, and you're done. Okay, so that was the first one. Second one, the second question is a product rule. Okay, so we're gonna do dy dx, right? Differentiating these two products, so you can assume this is your f, and this other one is your g, right? So plus the other one, on one, you're gonna differentiate x squared. On the other, you're gonna differentiate e to the power negative 3x prime. Okay? Or you can use bracket. And this step actually is dispensable. Okay, the derivative x squared is 2x, and you just copy e to the power 3, negative 3x, plus we keep the x squared, right, and we're going to differentiate e to the power negative 3x. How do we differentiate e to the power of negative 3x? Right, so e to the power of negative 3x. Okay, we know the derivative of e to the power x. Okay, so we know this. We know the derivative with respect to e to the power x. is equal to e to the power x, right? So now we don't have e to the power x, we have e to the power negative 3x. What do? Well, we treat the negative 3x as a u, right? So how do we deal with that? So to this, so look at this perspective, right? There's inconsistency. There's e to the power u dx. We're gonna do, what we're gonna do is that we're gonna divide, so we're gonna move the dx here. So we move the dx here, right? Still the same thing, and divided by du, multiply du. So that's essentially chain rule. And the derivative of the e to the power u with respect to u is e to the power u. And of course, that's negative 3x. And then we're going to differentiate u is negative 3x. All right. So this is going to be negative 3x. Oh, sorry, negative 3x. And the derivative of negative 3x is negative 3. All right. So that's how you do it. Or you can, you don't have to introduce the u explicitly, you can just introduce it implicitly. So in your mind, this is e to the power u with respect to x. There's inconsistency there. So you're going to differentiate e to the power of bologna with respect to bologna, which is going to be e to the power of bologna. And then you differentiate the bologna, which is negative 3. So either way, you get that differentiated. So this part equals to that. Don't forget this parentheses, okay? Many of us did forget the parentheses. Then you say, hey, I forgot the parentheses, but there's a dot. It doesn't matter, okay? If you miss the parentheses, it will be regarded as this piece is subtracting 3, which is not what we should have here. So you need this parentheses. And the next step, and of course, you're going to organize the term a little bit, right? Bring the negative 3 to times x squared, so you have a negative 3 here. And then you're going to factor out the e to the power negative 3x. Some of us have some trouble factoring this, right? You factor this out. Sorry. You factor this out. And then you realize, oh, I can factor out x. So you factor out an x, so x is out. Okay, so for the factoring part, you get, there's an extra point. Okay, product rule. Can you do this question any differently? Of course, you can do it differently. You can do it by quotient rule if you want. Okay, this is going to be e to the power of a positive 3x. So when we are doing dy dx, we will get to apply quotient rule, right? So you decide which one is f, which one is g. So I'm just going to, go forward. The denominator is being squared, right? And you differentiate the numerator, which is x squared, right? So we're going to wait a little bit to set up the formula, and then multiply e to the power 3x, right? The denominator subtracting, and this time x squared will not be differentiated, and differentiate the other one, e to the power 3x. It's e to the power 3x, not a negative 3x. Okay, simplify. Well, actually, we need to put the derivative in place. The derivative of x squared is 2x. and the derivative of e to the power 3x, right? So in this process, which we just did, what do we get? It was a positive 3x, right? So this is a positive 3x, so this is a positive 3. Okay? So this part equals to 3 times e to the power 3x. Okay? And then you can simplify. Right? You can factor out the e to the power 3x, right? That you can bring the 3 to the front of x squared and factor out e to the power 3x, right? You can also factor out the x. And e to the power 3x, take away one of the e to the power 3x in the bottom. So near the end, this will be left with just e to the power 3x in the denominator. And these two are the same. Okay, so x times 2 times, okay, e to the power 3x, we flip up, it's going to be e to the power of negative 3x. All right. So there are 2 ways to do it. The next one, okay, we have to use the chain rule first, okay? So when we differentiate f, of course, with respect to t, we see this as e to the power of, okay, I'm going to bring back to the other one, okay? So you see the similarity. Right? All right. Okay, right here. That part is my scratch paper, okay? Scratch paper. So if I have x here, the answer is going to be e to the power x. We know that, right? We know that. In this case, when x e to the power x differentiated with respect to x. But what if with respect to u? And there's inconsistency. What do? We'll take this, we take that, right? And move the dx over here, which doesn't change anything, and we divide it by du and multiply du. All right, it's very common practice, and this time the derivative with respect to u, e to the power u with respect to u is going to be e to the power u, and that part is du dx, right? So that's going to attach a du dx. So in our situation, the u is t times, okay? U is t times sine of 2t. Excuse me. So I'm going to assume that is u, right? That's my u. So my u is t times sine 2t. So this u here is going to be t times sine 2t. So over here, u will be replaced by its equal, which is the product. So here, that's why we're going to apply product rule. And in front of it is going to be e to the power u. E to the power u, of course, is e to the power t times sine 2t. All right? So please practice this yourself. Don't just watch and follow. Try it again and do it again. Prepare to do it 10 times. If you get it 5 times, great. If you do it 10 times, totally normal. Okay. All right, so we're gonna get e to the power of t times sine 2t, and then we're gonna do the product rule. When we do the product rule, we must enclose everything in the parentheses. Doesn't matter if it's a curly brackets. If it's a curly brackets, it's fine. If it's a parentheses, fine. But they have to be enclosed because we're gonna do product rule. Product rule generate two terms. Okay. We will see what parentheses per bracket or curly brackets we need. So let's start with parentheses, right? So now we're differentiating t times sine t. So this is the product, right? This is the product. We see it as a product of t with sine 2t. Okay, so your f is t, g is sine 2t. Oops. Okay, so I'm going to write this twice. I'm going to differentiate t, and then I'm going to differentiate sine 2t. Sine 2t. Then we got a parentheses and a parentheses outside. But in this software, you see it automatically parsed for us, right? What if it doesn't, right? This is the moment you can say, oh, I'm going to introduce brackets. I just don't want to get messed up. No problem, no problem. If you want to use a curly brackets here, fine, okay? The purpose of using these parentheses is to make a distinction or is to do some kind of parsing for us. The derivative t is 1, right? 1 times sine 2t, you can remove that. You can omit it, right? And over here, how do we differentiate sine 2t? How do we differentiate sine 2t? Same idea, okay? The derivative of sine x with respect to x dx equals to cosine x. Okay, in this formula, we have x here, x here, x there. These three places are consistent. But now we can differentiate it with t. Oh, sorry, this in the previous case, it should be t. Okay, sorry, there should be t. Sorry about that. All right. Okay, so now we have with respect to t. Let's do t. Then this will be t, right? This will be t. But now it's 2t. 2 times t. And differentiate with t, sine 2t differentiate with 2 dt. And that's not going to be cosine 2t, right? So what are we going to do with it? What are we going to do? Well, the same trick. We treat 2t as a u. Okay? And we scoot over a little bit and bring this dt over here. And we differentiate with respect to u du. That's an application of u. Okay? And our u is 2 times t. 2 times t. And the former, we're going to get cosine u, right? U, of course, is 2t. And the derivative of 2t is 2. We'll put a 2 there in the front. Why do I put it in the front? Because if I put it in the back, it may be confused as 2 times 2t. They should not go together. So for that reason, I bring the 2 in the front. So this part will give us what? Will give us 2 times cosine 2t. Okay? All right. Now just organize the term a little bit. Okay? And this makes 2t. And that's it. If you want to change this to parentheses, no problem. If you leave it as a bracket, that's fine. If you want to change it to curly brackets, that's no problem either. Can we do this in any other way? You could, but this might be the simpler case. This might be the simplest case, okay? Okay, the last one. Some of you were trying to do it by chain rule, which you can, okay? Some of you did a quotient rule, which is equally fine, If we do the chain, so I'm going to show you the two different ways of doing it, right? If we do chain rule, so we're going to differentiate. We're going to treat this as u. Okay, so we basically have this situation. The y is this root, right? So this is derivative we're trying to find. We know the derivative of, okay, so I'm going to use the bottom as my scratch paper, okay? The derivative of root x is equal to 1 over 2 times root x. Well, if you like to use negative exponents, that's fine with me too. And if this is u, and this is u, and that will be u, right? So there's always this consistency that we can use it, all right? The variable is just a placeholder, but this time, we get an inconsistency. So this is that, and this is x. So that's not going to work. Right? So we're going to view this piece as our baloney. Okay? We have derivative with respect to the root of baloney, but it's still with respect to x, right? Of course, we know baloney is x over x plus 1. Then what do? Right? We move the dx over here, divide by du, and multiply by du. So this way we can apply that formula. And what is our u? U is this piece. Okay, you don't really need parentheses here. It won't be confused. All right, so this part is equals to that. Right, and u is equals to x over x plus 1. So that's the first part of derivative. Okay, chain rule, the first chain rule. Okay, we apply the chain rule. And second part, we're differentiating, this is a quotient rule. So for quotient rule, we're just going to do whatever quotient rule is calling for, x plus 1 squared. Okay, people who did this part usually did pretty well. The derivative of x multiply x plus 1, right? Subtracting x, and the derivative of x plus 1 is 1. So that will lead us to the following case, right? X plus 1 minus x, that's going to be a 1. So if you get to this point, you're pretty good. Okay? So we can bring this one over here. Boom. Okay? And of course, you can reduce it. How do we reduce it? Okay? I do give extra point for reducing this, but so this part you're gonna get root x plus 1, right? Because that's in the denominator. Over here is a root x. And here we got this 1 over x plus 1 squared, okay? And this piece can be seen as x plus 1 to the power of half. Right? So this piece is viewed as x plus 1 to the power half. And this is power half, and this is power 2. And so the exponents subtract, right? Exponents subtract. So you can simplify to the ultimate form. That's going to be 2 minus half. 2 minus half, of course, that's just 3 half. Okay, so that's going to be a 3 half exponents. All right. Okay. So that's one way to do it, applying chain rule. Okay. And what if you say, okay, this chain rule, I don't get it yet. That's okay. For this particular one, right? You can write it down as some of you did it this way, which is some of you did it right, some partially right. Okay, but the effort is good, right? So that we can do quotient rule. So dy dx equals to, we got a denominator, that's the denominator squared. Oops. And differentiating the numerator, right? And multiply the denominator. You know that drill, right? Subtracting, and on the next term, right? I just copied it over, not differentiating this one, but differentiating this one. Equals to the derivative of root x. Okay, if you like to write it this form, I know some of you like to write it in this negative exponents, negative 1/2 form. That's okay. But this one, when you're differentiating this one, you also need to use chain rule. Okay, you also need to use the chain rule, even though it is not that it's not that difficult. Okay, so once again, so derivative with respect to root x equal to that one, right? We all know that. But what if it's x plus 1? And there's inconsistency. There's an inconsistency. What do we do? Well, in that case, okay, we move this over. We do the same trick again, right? So we move the x over there, and this is du. What do you think is u? U in this case is x plus 1. U in this case is x plus 1. The derivative of x plus 1 is 1. Okay, but this part, the derivative of root u with respect to u, which is going to be 1 over u raised to the power of negative half. Okay, the derivative of x plus 1 with respect to x is the derivative of a sum, and that's going to be equals to 1 because the derivative of 1 is 0. But this u here will be replaced by x plus 1. Okay, so that part of derivative for this piece is going to be this. Okay, so I'm going to bring that in place, right? If you get here, you got your points. You got 3 points. But if you can do a little bit further, you will get 1 more. Okay, so I'm going to show you how you simplify this. How do we simplify this? Right? How do we simplify this? And you use power. right? We can factor it out. This piece is going to be, this piece is x raised to the power of half. Oops, what am I doing? Power of half. Okay. And this is x to the power half. This is x to the power negative half. And there's a half here, right? So what I like to do is that I'm going to first factor out these half in the front. Oops. Wait. Factor the half to the front. Okay, so this half and this half factored out, bring it to half. Or I can say, okay, I'm going to just put a 2 over here. And some of these are exponent form, some of these are root form. Which form do you like, right? So we have root form in the denominator. So how about we use the root form, okay? That's 1 over root x, right? X raised to the power negative 1/2 is 1 over root x. And this piece is just the root x. You change it to the form that you're most familiar with, okay? X plus 1 to the power of a negative half. And that is 1 over root x plus 1. So now we change it to the everything root form. Everything root form. So let's take a look. And we put this one on the top. We're going to put this one on the top. And do we see a little bit better this time? All right. So what's the common denominator? All right, let's see. What is the common denominator? The common denominator will be root x multiply root x plus 1. So root x multiply root x times root x plus 1. So we do this because we want to get rid of the complex fraction situation. All right. So by doing so, okay, you're talking about you want to enhance your algebra, right? So you better follow me doing this so you can get better. Okay. So you take this to multiply that piece. I'm going to take that, you take that piece to multiply it. And this piece is going to multiply the denominator right here. So this part is no longer needed. On this piece, root x and root x reduced. So what do we have left? We have root x plus 1 squared. Yay, isn't that nice? I like it. We went through some hardship and realized we get something really simple, right? So we get root x squared on this side, right? And this gets to be more interesting, isn't it? So this is x plus 1, and this is x, right? Finally, that's just 1. All right, but this looks different from the answer we get earlier, isn't it? Right? The answer we get earlier is like this. So let's take a look. We have the 2 there. They're just expressed in different form, right? Now, all right. Root x plus 1 and root x plus 1 squared and root x plus 1. And this piece is really just x plus 1, right? So if I bring these two together, so this power is 1, and this one can be written as the power, okay, x plus 1 to the power of half. And that's going to be, they have the same base. So, oh no, sorry, this is not squared. is just x plus 1. Okay, because the square of root x plus 1 is x plus 1. So this power is 1, sorry. So 1 plus half, that's 3/2. So that's 3/2. Now I think they're the same. Now they're the same. Okay? So choose a form you like to work with. You can work with fraction exponents if you want. Okay, you can work with the fraction exponents you want. And I think this lesson is long enough. If you want to know how to work with the fraction exponents to start with here, ask me. Okay, ask me. I'll show you. Okay, but I don't want to make this too long. Thank you for watching. Have a good night.